Thank you, Peter, for the introduction. Hi, everyone. I'm Zhang, and I'm a PhD student from the Bartlett School of Sustainable Construction, University College London. Today, I'm going to present our work on towards fully automated code compliance checking of building regulations, especially focusing on the challenges with rule interpretation and representation. So this is just to give you an idea of the structure of this presentation, where I will be talking about the background of automatic compliance checking and some research guiding questions we have identified, the methodology we employed in this research, and there's some results and findings and challenges facing this area, and we propose some potential solutions. And so firstly, a little bit background of compliance checking for those who don't know. So it is a process that when before the design is finalized and moving on to the construction stage, the building design will be checked against rules typically found in laws, recommendations, etc. And as we can see on the graph, so the different colors means different actors involved in this compliance checking process, and the arrows means the knowledge exchanges in this process. So we can see that it is actually a quite complex process where multiple actors are involved, and there are lots of knowledge exchange in the process. And however, traditionally, compliance checking is conducted manually, which is very difficult, not just because I've mentioned that there are multiple actors and multiple knowledge exchanges, but also because there are just so many regulatory documents to be compliant with. For example, the graph shows the regulatory documents in the UK, and they have different hierarchies, so different constraint levels. Some you must comply with, and some just like some recommendations, the guidance, and they have complex interrelationships. And also, if you look at a single rule, the semantics, logic, and the knowledge embedded in the rules are complex because the rules are written in natural language, where human can understand it more easier than the computer. And also, so from the studies, a lot of scholars mentioned that the manual compliance checking process is just costly, time-consuming, and error-prone. And so it may lead to costly work and poor building performance. So to address this issue, the research community, also the practitioners, have come up with the idea of automatic compliance checking, which is defined by Eastman et al. In 2019 as the tool that does not modify the design, but assesses the design against the rules, constraints, or conditions, and the results, the checking results would be pass, fail, warning, or unknown. And especially unknown is for when the information is incomplete in the building model, the design model. And so this, in this ACC area, there have been two approaching perspectives, because obviously we know we need to check the building design against the regulations. So the research community have approached it either using the building model perspective or the rule perspective, where the former one that mostly deal with the easy query of the BIM model, things like that. And for the rule perspective, it's more focused on how to interpret the rules written in natural language to a computer-readable rule to enable the automatic compliance checking process. And we will be focusing on the rule perspective in this work, which is the yellow circle here, because this is a bottleneck of ACC as claimed by researchers, and this process takes up to 30% of the time to implement a rule. And so we've identified some research gaps and proposed some research questions in this area. Despite extensive research in the rule perspective of automatic compliance checking in the past many years, there's no research to synthesize the research themes and identify future research opportunities. So we did a systematic literature review to help to identify the themes and then propose some future directions. And specifically, the research questions are, what are the themes of ACC research in terms of the rule interpretation process and how are they related to each other? And secondly, what are the challenges facing ACC from the rule perspective? So the methodology employed is systematic literature review, where we basically did literature search and scopus and the 2 rounds of screening, where we screened out non-peer-reviewed articles and non-English articles, and also articles that does not have a focus on the rule perspective or the automatic compliance checking in the construction industry. And we also did some further analysis on the themes, their interrelationships, and the future research directions. So here are the results. So we found 3 themes in the rule perspective of ACC. And the first theme is rule classification, second theme is rule representation methods, and third theme is rule organization. So in terms of the rule classification, it mostly focused on the individual rule provisions. So not about the interrelationships between rules, because sometimes the different rules are interconnected. There are some cross-references among the rules. And also we found that most of the classifications use a single dimension of the criterion to classify these rules. So for example, Solheim and Easterman used the complexity of rules to classify rules into 4 categories. And also some criteria, although some researchers have multiple dimensions of criteria, but this criteria not carefully selected. And for the second theme, rule representation methods, so there are some groups of methods including production rules, language-driven rules, semantic-based rules, and semantic-based representations and logic-based representations. And what we found is they all seem to have some deficiencies, and no representation method can currently represent all types of rules. And for the last theme, rule organization, so I've mentioned that there's some interrelationships and cross-references between and among the rules. This area has been rarely addressed, but some researchers did focus on how to deal with the rule organization. And so, based on the literature review, we proposed several challenges in this area. And firstly, in terms of rule representation, the current development process of automatic compliance checking lacks a methodological backdrop because sometimes the researchers may not have a very clear purpose or objectives that they want to achieve, especially about the functionalities they want to have. And also, secondly, representing unknown and other set effects. So a lot of methods using logic programming, which only has true or false, but not the third value such as unknown, or sometimes we also need side effects, especially in like green building evaluation regulations, where we have some credits, add 1 credit if this is satisfied or things like that, so that we call side effects, and they cannot deal with that at the moment. And also some rule representations restricted by target data model, which is in most cases IFC model, and rule engine. So some rule engine may require specific programming language, and the computer readable rule are represented in that way. And in terms of regulations, there lacks a thorough understanding of rule texts. So it's currently the researchers may not know what are the requirements to fully represent these regulations with little knowledge loss. And also between these 2 aspects, there lacks knowledge of relationships between representations and rule type. So we proposed some potential solutions for these 5 challenges. Firstly, we proposed to use design science research to develop artifacts. And the steps of the design science research is shown on the right. We have several steps, and for the suggestion part, we need to have a thorough consideration of the objectives and the functionalities we want to achieve of this system. And then about the evaluation part, so lots of existing study did something like validation, so to test that the system can work, but usually there lacks user evaluation feedback to let the users actually use the system and provide some suggestions. And also for the evaluation and ex-ante evaluation that before the system is built can be done to suggest some features and thereby saving time and resources. For the unknown side effects, so it's important to provide some modeling guideline for the modelers to decrease the unknowns, and also can have some interface to supplement information. Also in terms of side effects, as I have explained earlier, so adding credits can be the side effect of a rule in some regulations, and we need to develop some domain-specific representation methods, not just maybe logic programming that only allows true or false. And in terms of the restriction by target model and rule engine, so we might need an intermediate way to link the target data model ontology and the rule ontology, such as a dictionary or some inference rules in semantic web. And this dictionary can also provide some descriptions and definitions of the concepts. And in terms of the understanding of rule text, so rules have the individual rule provisions and also the cross-references between them. The rule classification should deal with both of them. And also we recommend a consolidated list of aspects to categorize the rules, not just on the complexity or whether they are subject or objective. And in terms of the relationships between the representations and rule types, so this graph is to show the relationships between rule representation and the rules to be represented. So typically we need to understand the capabilities of the rule representation and the typical capabilities needed by the rules to be represented. So we suggested the following steps to firstly identify what rules are being represented and what are the features of the rules. And then we make comparisons of several potential representations, whether they are suitable for this type of rules, and then select and match the rules and the representations. So in conclusion, this work is a systematic literature review on the interpretation and representation of ACC. And we found 3 themes, including rule classification, rule organization, and rule representation. And we also found 5 challenges facing this area in the aspects of rule representation, regulation, and the relationships between them. And we suggested methodologically sound methods, such as using design science research to develop these systems. And we also need domain-specific representations that can address the side effects that is specifically in the construction industry. And also we may need some modeling guidelines to reduce the unknowns when we are checking the rules, checking the model against the rules. And also using an intermediate way to link ontologies might be useful. And fourthly, a consolidated list of aspects for rule classification and will be helpful, and considering the interrelationships of rules will be very useful. And the last one is follow the proposed steps on the previous slide to analyze the capabilities needed for the rule representation and match the rules and representations. And here's the reference list, and thank you very much for listening. And if you have any questions, please feel free to ask.